Hello everyone, I'm Jingjing Zhang. Today I will present the topic about Kafka. First, let's look at the outline. We will see the background information firstly. Second, how does Kafka work? Third, data replication and distribution. The fourth is about streaming. Lastly, we will see when to use Kafka. First, let's look at the background information. Why Kafka? As distributed systems and services increasingly become part of a modern architecture, this makes for a fragile system. So point-to-point data pipeline are problematic. Kafka decouples data pipeline, as we can see from the figure, the right side. Kafka is a distributed, horizontally scalable, fault-tolerant commit log. Here are some fancy words. Distributed system are designed in such a way to accommodate failure in a configurable way. The first fancy word is the horizontally scalable. So if you have a traditional database server which is starting to get overloaded, the way to get this solved is to simply increase the resource on the servers. Such as CPU, RAM, SSD. We call this vertical scaling, adding more resource to machine. But vertical scaling has two disadvantages. So one is there are limits defined by the hardware, right? Another is it is usually required downtime, something with big company cannot afford. Horizontal scalability is solving the same problem by adding more machine at it. So there is no downtime for adding more computers, and there is no limit to the number of computers that can be in the cluster. As we can see in the picture, the vertical scalability costs rise sharply after a certain point, but horizontal scalability becomes much more efficient after a certain point. Let's look at the commit log. A commit log is a persistent ordered data structure which only supports appends. You can not modify or delete record from it. It is record from left to right and guaranteed item ordering. This structure is at the heart of Kafka, as it provides ordering, which in turn provides deterministic processing, both of which are non-trivial problem in distributed system. Kafka stored all of its messages to disk, having them ordered in the structure lets it take advantage of sequential disk needs. Disk seeking is expensive, right? So Kafka has a huge advantage because its reads and writes are a constant time compared to other structures. Also, reads and writes do not affect another. So the writing would not lock reading and vice versa. That means the data size is completely decoupled from performance. For example, Kafka has the same performance whether you have 100 KB or 100 TB of data on your server. Moving to how does Kafka work? Professor Saw has already introduced the basic concept of Kafka in the latest video. So the producer sends record to the broker, and the message is processed by the consumer. The message gets stored in a topic, and the consumer subscribes to the topic to receive new message. As topic can get quite big, they get split into partition of a smaller size of for better performance and scalability. Kafka guaranteed that all messages inside a partition are ordered in the sequence they come in. The way you distinct a specific message is through its offside, which you could look at a normal array index, a sequential number which is incremented for each new message in a partition. Kafka follows the principle of a dumb broker and a smart consumer. So in other words, Kafka does not keep track of what records are read by the consumer and delete them, but rather stores them a set amount of time or until some size threshold is met. So consumers themselves pull Kafka for new message and say what record they want to read. As we can see from the picture, the consumer group A read from partition 1 starting at offside 2, right? This allows the consumer to increment, decrement the offside there as they wish, therefore being able to replay or reprocess event. So it is worth noting that actual consumer groups which have one or more consumer process inside. In order to avoid two process reading the same message twice, each partition is tied to only one consumer process per group. Partition data is replicated across multiple brokers in order to preserve the data in case one broker dies. So a partition leader means that all time one broker owns a partition, and it is the node through which applications read from partition. It replicates the data is received to other brokers called followers. So followers store the data as well as and are ready to be elected as leader in case the leader node dies. As we can see from the picture, orange means replicate, right? So they have replicated the data here. This can guarantee that any successfully published message will not be lost. But you may be asking, how does a producer consumer know who the leader of a partition is, right? We can see from the picture. So for a producer consumer to read from a partition, they need to know its leader, right? This information needs to be available from somewhere. And Kafka stores such metadata in a service called Zookeeper. We have learned the concept of Zookeeper from this course. Zookeeper is a distributed key value store. It is highly optimized for read by write store. It is most commonly used to store metadata and handle the mechanisms of clustering. Zookeeper allows the Kafka broker to subscribe and have changes sent to them once they happen. Zookeeper is also extremely fault-tolerant and is ought to be, right? Because Kafka highly depends on it. So overall, it is used to sorting all sorts of metadata. For instance, the partition leader and their house, producer, consumer costs, and consumer groups offside per partition, something like that. And the producer and consumer used to directly connect and talk to the Zookeeper to get this information. Kafka has been moving away from this copying, and since version 0.8 and 0.9 respectively. Moving to the streaming. So in Kafka, a stream processor is anything that takes continuous streams of data from input topic, performs some processing on this input and produce a stream of data to output topics. Kafka provides an integrated stream API library. This API is intended to be used within your own data code base. It is not running on a broker. It works similar to the consumer API and help you scale out the stream processing work over multiple applications. The stateless processing of a stream is deterministic and does not depend on any external conditions. You know that for any given data, you will produce the same output regardless of any other data, right? So as we can see from the picture, the filter out invalid login request, right? And then we got the valid user login request there. Moving to the stream table duality. It is important to recognize that stream and tables are essentially the same. A stream can be interpreted as a table, and a table can be interpreted as a stream. As you can see in the picture, each record increments the aggregated count, right? A table can be looked at as a snapshot of latest value for each key in a stream. In the same way, stream records can produce a table. Table updates can produce a changelog stream. So from the picture, we can see each update produce a snapshot record in the stream. But in real life, most operations we met will be the stateful, and that will require us to store the currently accumulated state. The problem with maintaining state on stream processor is that the stream process can fail. Where would you need to keep this state in order to be fault tolerant? Right? Actually, this is the key part. So what is the best method? Recall the duality of the table and the streams. This allows us to convert streams into tables that are co-located with our processing. It also provides us with a mechanism for handling fault tolerance by storing the stream in a Kafka broker. A stream process can keep this state in a local table, which will be updated from an input stream. When the process fails, it can restore its data by replaying the stream, right? So you could even have a remote database by the producer of the stream, efficiently broadcasting a changelog with which you rebuild the table locally. Finally, let's look at when to use Kafka. So Kafka allows you to have a huge amount of message go through a centralized medium and store them without worrying about things like performance or data loss. So in other words, it is perfect for use at the heart of your system architecture, acting as a centralized medium that connects different applications. Kafka can be the centerpiece of an event-driven architecture and allow you to truly decouple applications from one another, right? I have mentioned this before. Kafka allows you to easily decouple communication between different servers. With the Stream API, it is now easier than ever to write BAS. Overall, the Kafka has grown in popularity. The key reason is that nowadays business benefits greatly from event-driven architecture. Moving to summary. Kafka is able to process streams of events. It is low latency, high throughput, fault-tolerant publish and subscribe pipelines. Kafka is a distributed streaming platform. We went through basic semantics, including producer, broker, consumer, and topics. We also figure out how Kafka replicate data to be fault-tolerant. I didn't get a chance to mention, but nevertheless it's important to know, such as log compaction, controller broker. This is the link. We can see the basic of Kafka in 2 minutes. Let's see the video now.
I'd like to tell you what Apache Kafka is, but first I want to start with some background. For a long time now, we have written programs that store information in databases. Now, what databases encourage us to do is to think of the world in terms of things. Things like, I don't know, users, and maybe a thermostat. That's a thermometer, but you get the idea. Maybe a physical thing like a train. Let's see here, train, things. There are things in the world. Database encourages us to think in those terms, and those things have some state. We take that state, we store it in the database. This has worked well for decades, but now some people are finding that it's better, rather than thinking of things first, to think of events first. Now, events have some state too, right? An event has a description of what happened with it, but the primary idea is that the event is an indication in time that the thing took place. Now, it's a little bit cumbersome to store events in databases. Instead, we use a structure called a log. And a log is just an ordered sequence of these events. An event happens, and we write it into a log, a little bit of state, a little bit of description of what happens, and that says, hey, that event happened at that time. As you can see, logs are really easy to think about. They're also easy to build at scale, which historically has not quite been true of databases, which have been a little cumbersome in one way or another to build at scale. Now, Apache Kafka is a system for managing these logs. Using a fairly standard historical term, it calls them topics. This is a topic. A topic is just an ordered collection of events that are stored in a durable way. Durable meaning that they're written to disk and they're replicated. So they're stored on more than one disk, on more than one server, or somewhere, wherever that infrastructure runs, so that there's no one hardware failure that can make that data go away. Topics can store data for a short period of time, like a few hours, or days, or years, or hundreds of years, or indefinitely. Topics can also be relatively small, or they can be enormous. There's nothing about the economics of Kafka that says that topics have to be large in order for it to make sense, and there's nothing about the architecture of Kafka that says that they have to stay small. So they can be small, they can be big, they can remember data forever, they can remember data just for a little while, but they're a persistent record of events. Each one of those events represents a thing happening in the business. Like, remember our user, maybe a user updates her shipping address, or a train unloads cargo, or a thermostat reports that the temperature has gone from comfy to is it getting hot in here. Each one of those things can be an event stored in a topic, and Kafka encourages you to think of events first and things second. Now, back when databases ruled the world, it was kind of the trend to build one large program. We'll just build this gigantic program here that uses one big database all by itself. And it was customary for a number of reasons to do this, but these things grew to a point where they were difficult to change and also difficult to think about. They got too big for any one developer to fit that whole program in his or her head at the same time. And if you've lived like this, you know that that's true. Now the trend is to write lots and lots of small programs, each one of which is small enough to fit in your head and think about and version and change and evolve all on its own. And these things can talk to each other through Kafka topics. So each one of these services can consume a message from a Kafka topic, do whatever its computation is that goes on in there, and then produce that message off to another Kafka topic that lives over here. So that output is now durably and maybe even permanently recorded for other services and other concerns in the system to process. So with all this data living in these persistent real-time streams, and I've drawn 2 of them now, but imagine there are dozens or hundreds more in a large system, now it's possible to build new services that perform real-time analysis of that data. So I can stand up some other service over here that does some kind of gauge, some sort of real-time analytics dashboard, and that is just consuming messages from this topic here. That's in contrast to the way it used to be, where you ran a batch process overnight. Now, it's possible that yesterday is a long time ago for some businesses now. You might want that insight to be instant or as close to instant as it could possibly be. And with data in these topics as events that get processed as soon as they happen, it's now fairly straightforward to build these services that can do that analysis in real time. So you've got events, you've got topics, you've got all these little services talking to each other through topics, you've got real-time analytics. I think if you have those four things in your head, you've got a decent idea of kind of the minimum viable understanding, not only of what Kafka is, which is this distributed log thing, but also of the kinds of software architectures that Kafka tends to give rise to. When people start building systems on it, this is what happens. Once a company starts using Kafka, it tends to have this viral effect, right? We've got these persistent distributed logs that are records of the things that have happened. We've got things talking through them, but there are other systems. I mean, what's this? There's this database. There's probably going to be, another database out there that was built before Kafka came along, and you want to integrate these systems. There could be other systems entirely. Maybe there's a search cluster. Maybe you use some SaaS product to help your salespeople organize their efforts. There's all these systems in the business, and their data isn't in Kafka. Well, Kafka Connect is a tool that helps get that data in and back out. When there's all these other systems in the world, you want to collect data, so changes happen in a database, and you want to collect that data and get it written into a topic like that. And now I can stand up some new service that consumes that data and does whatever computation it needs on it now that it's in a Kafka topic. That's the whole point. Connect gets that data in. Then that service produces some result, which goes to a new topic over here. And connect is the piece that moves it to whatever that external legacy system is here. So Kafka Connect is this process that does this inputting and this outputting, and it's also an ecosystem of connectors. There are dozens, even hundreds of connectors out there in the world. Some of them are open source, some of them are commercial, some of them are in between, but they're these little pluggable modules that you can deploy to get this integration done in a declarative way. You deploy them, you configure them, you don't write code to do this reading from the database, this writing to whatever that external system is. Those modules already exist, the code's already written, you just deploy them, and Connect does that integration to those external systems. And let's think about the work that these things do. These services, these little boxes I'm drawing, they have some life of their own. They're programs, right? But they're going to process messages from topics, and they're going to have some computation that they want to do over those messages. And it's amazing. There's really just a few things that people end up doing. Like, say you have messages, these green messages. You want to group all those up and add some field, like come up with the total weight of all the train cars that passed a certain point or something, but only a certain kind of car, only the green kinds of cars. And you've got these other, say you've got these orange ones here. So right away we see that we're going to have to go through those messages. We're going to have to group by some key, and then we'll take the group and run some aggregation over it, or maybe count them or something like that. Maybe you want to filter. Maybe I've got this topic, and let's see, make some room for some other topic over here that's got some other kind of data. And I want to take all the messages here and somehow link them with messages in this topic and enrich. When I see this message happen here, I want to go enrich it with the data that's in this other topic. These are common things. If it's the first time you've thought about it, that might seem unusual. But those things, grouping, aggregating, filtering, enrichment, enrichment, by the way, goes by another name in database land. That's a join, right? These are the things that these services are going to do. They're simple in principle to think about and to sketch, but to actually write the code to make all that happen takes some work, and that's not work you want to do. So Kafka, again, in the box, just like it has Connect for doing data integration, it has an API called Kafka Streams. That's a Java API that handles all of the framework and infrastructure and kind of undifferentiated stuff you'd have to build to get that work done. So you can use that as a Java API in your services and get all that done in a scalable and fault-tolerant way, just like we expect for modern applications to be able to do. And that's not framework code you have to write. You just get to use it because you're using Kafka. Now, if I wanted to do some sort of analysis on the data in this topic and I didn't want to put it in this service, I didn't want to stand up a Java application to run it, Confluent has a language called KSQL that I can now write some very SQL looking thing here, select from this topic, group by, etc. I won't write the whole query out, but it's a SQL-like language that I can run to be able to do real-time analysis of data in a topic. Where do those results go, you're wondering? Well, I think you'll be unsurprised to hear that the output of this query just goes into another topic, which I can then do further analysis on, stand up other services to process, use Kafka Connect to send to a legacy system. It all kind of fits into the platform. And when I say platform, Confluent Platform is a distribution of Apache Kafka that you can use in a number of ways. Number one, there are open source and community license components of Confluent Platform that are free to use. There's a lot of these connectors, there's KSQL, components like that. You can just download and use for free. There are other components of Confluent Platform that come with an enterprise subscription. Things like multi-data center support, enterprise-grade subscription, and things like that. Even those, of course, if you just want to go download it and use it, are free to use on a single node. So nothing is stopping you from experimenting even with those subscription features. And if the idea of downloading and installing and running on your own infrastructure seems old-fashioned to you, you can also use Confluent Cloud. Confluent Cloud is a fully managed serverless Kafka in the cloud. It lets you get all of this kind of thing done without thinking about infrastructure at all.
Okay, that's all for my presentation. Thanks for your time for listening.